Hello. We're going to look at using the properties of exponents, along with our understanding of graphs and tables, to help us see if we can figure out a nice way to solve equations that are exponential in nature. That is, equations where the variable happens to be in the exponent of the function, or equation. So the first thing I'm going to do is I'm going to look at 3 to the x plus 1 as a transformation of y equals 3 to the x. By way of quick review, I know that 3 to the x has 3 to the 0, which is 1, 3 to the 1 is 3, and 3 to the negative 1 is 1/3. The rest of the points are either going to go rapidly up or asymptotic to the x-axis. So the 3 to the x graph is a basic exponential growth curve starting at 1 and then tripling and going a third in opposite direction. So if that's true, then the 3 to the x plus 1 is going to look exactly like the 3 to the x function, only it will have been shifted to the left 1. So instead of 1, 0, we're going to, or 0, 1, we're going to go negative 1, 1. And instead of 1, 3, we're going to go with 0, 3. And instead of 2, 9, we're going to go with 1, 9. So the next thing I need to do is put in a line for y equals 1/27. It's really tough to see, but this 1/27 is a very small number, so it's very close to 0. And even if my graph is poor, I can see that the intersection of the line and the curve is going to be somewhere in the negative realm, clearly well beyond x equals negative 1. So to get a better sense, I'm going to use a table of values instead. And this time I'm going to know that I'm looking for negative values of x, so I'm going to start with 0. And there I find that when x equals 0, 3 to the 0 plus 1 is 3 to the 1, which is 3. When x is negative 1, 3 to the negative 1 plus 1 is 3 to the 0, which is 1. Following on with the pattern, I eventually learn that when x equals negative 4, y equals 1/27, which is my target. That means my solution is x equals negative 4. Now that's great, but I'm trying to learn algebra in this particular course, and so the question now becomes, how would I use algebra if I could use algebra instead of using a guess and check method as I did with the table? So the key here is that both the number 3 and the number 27 are both what we call powers of 3, or multiples of 3. 3 is 3 times itself, and 27 is 3 times itself 3 times, or 3 to the third power. So I'm going to write 27 as 3 to the third power. Then to make it even better to see the relationship between these two numbers, 1 over 3 cubed is the same as 3 to the negative 3 power. So I just basically make the exponent negative and go on from there. Now comes the logic. This is the only new part of this lesson. That is, in an exponential equation, if we have 3 to 1 power, it's the same value as 3 to another power. The only way that could ever be true is if the powers themselves are equal. So when I see the statement 3 to the x plus 1 is the same number as 3 to the negative 3, that can only mean that x plus 1 has to equal negative 3. Simple linear equation, solved in one step, x equals negative 4, which has already been confirmed. So now I have algebraic, tabulature, and graphical analysis to solve this equation. Another example, 8 to the x plus 2 equals 32. Quickly graphing, I see that it's going to be 8 to the x shifted to the left 2. So instead of 0, 1, I'm going to be at negative 2, 1, negative 1, 8, and 0, 64. Creates that graph. Y equals 32 is a horizontal line right about there. And it shows me that my solution is going to be a negative number, but it's a number between 0 and negative 1. My graph looks like it's around negative 1/3. Maybe it's sloppy. Maybe it's negative 1/2. We need to find out. I don't learn much more from my table, because I see when x equals 0, we have 8 to the 0 plus 2, which is 8 squared. And that gives me 64. When I put in negative 1, I get 8 to the negative 1 plus 2, which is 8 to the 1. 8 to the 1 is 8. I'm looking for 32. Since 32 is somewhere between 64 and 8, the question is, what power am I going to use? And the answer is something between 0 and negative 1, which is the same thing I got from my graph. So in your work, you could use either a table or a graph to make some sort of claims about what the value of x should be. And then we're going to use our algebra to go further. When I look at 8 and I look at 32, I recognize that 32 is not a power of 8. So I'm going to have to try to rewrite this in such a way that they have the same bases. 8 is a power of 2, and 32 is a power of 2. So we're going to do 8 and 2 and write them both as powers of 2s. So 32 is 2 to the 5th. 8 is 2 cubed. So instead of 8 to the x plus 2, I'm going to write 2 cubed to the x plus 2. That equals 2 to the 5th. Off you go. distributing the exponents, because this is power of a power, we're supposed to have 2 cubed that many times, creates this. And now in order for those two to be the same, their exponents must be the same. And I solve for x and get x equals negative 1/3. Just to be absolutely sure, I substitute negative 1/3 into my original equation, which gives us 8 to the 5/3. 8 to the 1/3 is 2. 2 to the 5th is 32. I win. Have a good day.